Good evening, children. Today we are going to learn the second part of the Newton's second law. In your previous classes, you have thoroughly learned about Newton's first law and second law. Continuing the last class, today I am going to present you a good and an important topic, that is Atwood machine. This is the application of the Newton's second law. Dear students, most of you are familiar with elevators. Commonly we call it as lift. చూస్తుంటాం కదా లిఫ్ట్లు పెద్ద పెద్ద అపార్ట్మెంట్స్లో మనం పైకి వెళ్ళాలి అంటే we make use of lifts. సో అలాంటి లిఫ్ట్లు ఇంకా చెప్పాలి అంటే లైక్ ఐఫిల్ టవర్ చాలా హైట్లో ఉంటుంది కదా ఐఫిల్ టవర్. మరి అంత ఐఫిల్ టవర్ని మనం ఎక్కాలి అంటే చాలా రిస్క్, అందుకే హై స్పీడ్ ఎలివేటర్స్ వాడుతుంటారు. ఇలాంటి అన్ని కూడా డిపెండ్ అయ్యేది ఈ అట్వుడ్ మెషిన్ ప్రిన్సిపల్ మీదనే అవన్నీ కూడా తయారు చేయబడతాయి. టుడే వీఆర్ గోయింగ్ టు లెర్న్ డీటెయిల్ అబౌట్ ద అట్వుడ్ మెషిన్ అండ్ ఇట్స్ mechanism. So as I told you, this is the application of Newton's second law. So we have to recall it, Newton's second law. So as per Newton's second law, we know F is equal to m into E. That is, the force is equals to the mass of the body and its mass of the body into acceleration. That is the product of mass and acceleration. This is the one formula of Newton's second law. Newton's second law can be expressed in other terms also. According to Newton's second law, the acceleration of a moving body is directly proportional to the force acting on it. That is the first statement. And the second one is the acceleration is inversely proportional to the mass of the body. That is the second one. So notice these two principles, and one more formula you have to know, that is the weight of a body. Weight of any object is given in the form of this formula. Weight of the body is equal to mass of the body and the gravity. That is gravitational acceleration. That is in short form it is Z. That is a constant. The value is 9.8 meter per second square. That you know very well. So these two things you keep in mind while solving this Atwood machine formulas. So first of all, let us get into the history of this Atwood machine. Actually, this was invented in the year of 1784 by George Atwood. Now let us see the construction of the Atwood machine. You will see the picture of Atwood machine on the screen. I will show you later. Okay, this is the FBD of the Atwood machine. This is the pulley. Pulley is fitted to a fixed base. This is a inextensible string that is not stretched. Even though we apply force, it is not stretchable. So inextensible string. There are two masses. This is M1. This is M2. Obviously, M2 is greater than M1. This is a big load. This is a small load. These two loads, that is, these two masses are attached to the string on either sides. So what happens? For example, initially these two are kept like this, equal height. If you take back your hand, what happens? Automatically it moves down and it goes up. It is quite natural. Because of it is a heavy load, it is a lighter load. Compared to M1, M2 is greater value in terms of mass. So automatically the string moves over the pulley. It is a pulley. Actually, it is a wheel. It is also called as a pulley. So the string moves over the pulley. So it comes down and it gets back. Here we have to observe that the push, the going up acceleration and the coming down acceleration. The going up acceleration of the M1, let us say it as A, and the this one, the acceleration of M2, that is also equals. So both the going up acceleration, the coming down acceleration of the masses are equal. So the acceleration of the moving bodies M1 and M2 are equal. Let us say the tension of the string is T. That is T. It is T. T is a form of force that you know, that is that present in the string like things. So that we can know detail later. So T is the tension of the string. So M1 is the mass of the body. A is the acceleration with which the mass M1 goes up, and T is the string tension of the string. So it is clear. Coming to this mass M2, M2 is the mass of this body. Acceleration same as this one. Acceleration moving down. This M2 is moving down with the acceleration A. Same acceleration as M1 moves up. T is the tension. One more thing, the weight of M2 and the weight of M1. As you know, the weight always in the direction towards the ground. That is mass. As we defined earlier, the weight is defined as the product of mass and gravity. Here it is M1 into G. So here it is M2 into Z. These are the weights. See, on this mass M1, two forces are applying. One is M1G, that is equals to its weight. Another one is tension force, that is T. T is in this direction, M1G is, that is weight is towards the ground. Here also, like T is string upwards and M2G is downwards. So when two or more forces acting on a body, the resultant force must be in the direction of the motion of the body, that we know. Now let us find out the F net. F net on this system and F net on this system also. For example, here for this set, for mass M1, F net is equal to, according to the Newton's second law, F is equal to ma. Here m is m1, a is the mass of the body, that is a. And moreover, one more force is there, that is F is equal to, F net is equal to, here the net force is tension force and the weight. So actually the mass is going up. That means the tension force is greater than the weight of the body. That is why the body is pulling up. So T is more value than the M1G. So students, understand this one. Here also two forces are acting on the body. One is in this direction, another one is in this direction towards the ground. That is the weight of the body. So we have to find the F net. F net is this word force minus this word force, because T is greater than the M1G. That is why the equation is like this. So these two are indicating the same value. Therefore we can write it M1A is equal to T minus M1Z. Say it as equation 1. Now let us move to the mass M2. Like this, here also, according to the Newton's second law, F net or F is equal to mass into acceleration, that is mass M2, acceleration is A. Here also tension force is acting this side, and the weight of the mass M2 acting towards the ground. So there must be a resultant force, that is F net, F net is equal to, here the tension force is less than the weight of the body. That is why we write it as m2z minus t. Say it as equation number 2. Okay, we can further write m2a is equal to m2z minus t. This is the equation number 2. Now let us try to solve these two equations. Write down one by one. So m1a is equal to t minus m1z. m2a is equal to m2z. Let us write it as we can write it first t, that is the minus t, that is plus m2z. So let us solve this for a. For that we have to eliminate the t. By adding we can eliminate t. So a is the common, then m1 plus m2a is equal to, here tt gets cancelled, m2 minus m1 into z. Let us solve for a, then we will get a is equal to m2 minus m1 into z by m1 plus m2. So this equation gives us the acceleration of this system. So m1 and 2 are the masses of the load attached to the string. Then we can observe that the acceleration g is a constant. The acceleration is dependent of the difference of the masses. The difference of the masses. So this is the equation to find out the acceleration of two bodies with which they move upward and downward. So if we solve this equation 1 and 2 for t, then we will get, after solving this, we will get t is equal to 2 into m1 m2 z by m1 plus m2. Yes, we can solve the equations for this t also. So the Atwood mechanism, Atwood machine, with the help of Newton's second law, we can find out the acceleration and the tension of the string. In this way, we can also find out the inertia of the pulley also. All these things gives us an idea of constructing an elevator. Thus, we can find out how much load an elevator can sustain. So students, so this is the Atwood mechanism and Atwood machine. The main application of the Atwood machine is, it is used in the construction of elevators. Okay, thank you children. Thank you very much. Okay children, see the picture of original Atwood machine. Students, now we are going to learn one more important topic, that is Newton's third law. To understand this, let us see an interesting video. Definitely you will enjoy the video.
Oh.
Hey!
Liftoff of the Delta rocket carrying GLAST, a gamma-ray telescope searching for unseen physics in the stars of the galaxies. T-minus 2, 1. Ignition.
So to perform this activity, we need a balloon, a beautiful balloon, and a piece of straw, and the straw is sticked to the balloon with a tape, cellophane tape, and a thread, of course. First inflate the balloon and tie its neck properly so that no air is leaked, like this. And through the straw, take a thread and tie it its two ends to one end here, and for example another one there. Hold the neck of the balloon tightly and untie the rubber band or anything else.
It's funny when you twins. You like it? Start. I like it. this activity. So like this. Now let us, shall we go? Let us see the magic. I am releasing the neck.
Hi students, just you have seen an experiment, an activity, a fun game. So what happened when I released the neck, the balloon was that end. So how it happens? Actually, now see, as you know, the air exerts pressure in all the directions. For example, this is the arrow shows the direction of the air in the balloon. So like this, like this, like this, like this, and all the way the air exerts pressure inside the balloon. When we release the neck, what happens? The air in this way comes out. So here there happens to be an low pressure area. So the pressure is there, pressure is there, pressure is there. Pressure also is there in this direction, but not in the direction. The pressure decreases in this direction. To compensate the decrease in the direction, so it is low pressure, then the pressure remains the same. That means it is the high pressure. Then what happens? This side it is balanced. This side also the pressure is balanced, except this side, because this side the air is passed through the neck. So there is a low pressure. So opposite, what happens? The pressure is high. Then the balloon simply goes up. So, for example, this is the coming out of air is a reaction. Then there is a opposite reaction in this way. For this action, there is a opposite reaction. That is quantity is same, but the direction is different. With this experiment, we can confer that for every action there is equal and opposite reaction. This is nothing but Newton's third law. Now let us see some more examples for Newton's third. Children, see the picture carefully. Two bodies A and B are interacting and exerting the force, equal amount of forces on each other. A is exerting the force on B. In turn, B also is exerting the same amount of force on A, but in the opposite direction. That means no single isolated force exists in interacting bodies. Not like the Newton first and second laws, Newton third law can be applied to the two body system. Children, first tie a few water filled big test tube to a retard stand and close it with a cork. Heat the test tube with a spirit lamp until water starts boiling. You can see the cork blows out and the test tube gets moved back. Now let us see what happens. Now we are heating the test tube. Yes, the water heating up gradually. After reaching its boiling point, the vapor comes out and the cork is blown out. Here, the vapor blows out the cork is an action. Test tube moved back is a reaction. Both are in opposite direction. Now, we are going to perform one more activity to verify the Newton third law. Here we have taken two spring balances which are equally calibrated. they are maximum weight to measure is 1 kg. Here also it is 1 kg. So both are equally calibrated. Now they are attached to each other like this. Both the hooks are jointed. See, this system is attached to a base. Now what happens to the reading? See, I am just applying the force on the system of two spring balances. Now observe the readings. Here it is 400 grams, that is 0.4 newtons. Here also it is showing 400 grams, that is 0.4 newtons. See, once again, see how they are, how the spring, how the indicator is moving. See, here it is moving this side, this one moving this side. That means the applied force on the system of interacting two objects, one is applied, this one is applying the force on it, and this one also applying the same force on this one in opposite direction. That's what Newton's third law once again verified. Okay children, try to answer these questions. Take the help of your teacher if needed, and also try to make a water bottle rocket with the help of your teacher. With this, we come to end of today's class.